We're going to have a look at the integrals of functions that have an interval that goes to infinity. That might not make a lot of sense right away, taking the integral of a function whose interval goes to infinity, because if this keeps going this way, people naturally would think that the area would be unlimited. That is what the integral is trying to find, the area. If the graph keeps expanding to the right, how will it be possible to calculate the area? And most of the time, it's going to be true that the area will be unlimited. But what this is really going to focus on are situations where we have an interval that goes to infinity, but there is still a definite area. We'll begin by trying to find the area of 1 over x. And what this is going to show is an example where the area is infinite. There is no defined area. And then we'll move on to the second example, 1 over x squared, which does have a definite area. And while these two graphs look similar, one has a definite area, the other does not. The other one has an unlimited area. We'll begin with 1 over x. And hopefully by showing both of these examples, we'll be able to see why one does have a definite area and the other does not. First thing I'll do is replace this infinity with t, and a with 1. Then integrate. So I've integrated it thus far, but in order to figure out if there is a definite area for underneath this curve, I'll need to take the limit as t goes to infinity. This is going to be equal to the natural log of infinity minus natural log of 1. It's just going to go to infinity. So the limit does not exist. No limit. If there is no limit as I go to infinity, then that means there's no definite area. Now for the second example. Actually, it'll be easier if I put it this way. Now take the limit as t goes to infinity as well. Here's the situation where it's 1 minus 1 over infinity. 1 over infinity is going to go to 0. And this leaves a 1, which is a definite area. What these two examples have shown is as t goes to infinity, the area for this one is equal to infinity. It has no defined area. But this one, the area is equal to 1. And the reason for that is because both of these graphs look very similar, is that the one on the right, the graph approaches 0 fast enough to have a defined area, where this one, it doesn't get to 0 quickly enough. So it has an unlimited area. And they have special terms for these two things. If it does not approach 0 fast enough, it's said to be divergent. If it approaches it quickly enough and it has a defined area, then it's said to be convergent. And here's a quick helpful tool that not all of the examples or problems that we'll come across will be in this form, but 1 over xp, if p is greater than 1, it's convergent. If p is less than or equal to 1, it's divergent. Obviously, this wouldn't be helpful if there's a trigonometric function or something different in there, but it's better than nothing, I guess. But this is all we have to do. We just have to substitute in wherever the interval is beginning from, and then have it go to infinity, and then figure out if there is a limit as it goes to infinity or not. If there is a limit, then it's convergent and it has a definite area. If there is no limit, then it's divergent and it has no area.